Today we're going to talk about series and parallel circuits. Before we start the whole topic here, I want you to look over the schematics that we have, the symbols for schematics that we have here, just to familiarize yourself with what these things mean. A power supply can also be a battery. Obviously a wire is a conductor. Resistors, a lamp being a light bulb. A motor is any electrical motor that is going to make a physical action happen. And a switch, well, that's pretty obvious there what that is. So before we get into the whole bits of series and parallel, I want to talk about electron flow and how it actually works in a circuit. So I have here a very simple circuit here, and with this current setup, with the switch being open currently, there is absolutely no electron flow. However, when we close the switch, electrons can flow. The question is, which way do they flow? There's two thoughts. There's going to be the conventional theory. Conventional theory is that electrons flow from positive to negative. And that was kind of the original thought for a long time. The more modern thought is that the electrons flow from negative to positive. This is called the electron flow theory. This is what most scientists use for their expertise in their areas. So we're going to use electron theory for most of our topics here in class, but that's kind of the way that there's differences between those two opinions. Regardless of how they flow, the actual circuit will still work the exact same way. It's just a different way to look at the electron flow in a circuit. So we're going to look at two different circuit types here. We have series and parallel. On the left, I see a series circuit setup, and on the right is my parallel. With both of these systems here, they're very different in how they're organized. On a series circuit, it's kind of like when you have a string of lights, that if one light bulb burns out, the entire strand burns out. So the same idea as a switch. If I have a switch that is closed, so I'm going to close my switch here, current can flow around the circuit. Now, let's say this bulb here burns out. If that bulb burns out, it's the same thing as saying a switch is opened up, which means that there's no more electron flow, so both bulbs will no longer turn on. So in a series circuit, we have one path for current to flow. I want to look at parallel really fast to kind of counteract the series circuit design. On a parallel circuit, when you close the actual switch here, again, electrons can flow. Now in this case, electrons have two paths to follow, one here and one here. With those two different paths, now I have a different opportunity here for current to move if one light bulb burns out. So if my inside light bulb burns out, it doesn't matter because this outside bulb will still receive current because there is no break in that path. So we'll go ahead and kind of carefully erase some stuff here. And we can talk about Kirchoff's laws. There's two laws to understand here between each of these two circuits. There's Kirchoff's current law and Kirchoff's voltage law. On Kirchoff's current law, what this law is kind of stating as a whole is that amperage is constant. Throughout the entire system, amperage is constant. So the flow of electrons is the exact same anywhere in the entire system. But voltage will change. Voltage will drop. And the total voltage is equal to each summation, the summation of all the voltages at each point. So we'll get into that in its use in a minute here. What we would need to know right now is that amps is constant and that volts vary. Now amps are constant because the electron flow has only one path to follow. So there is no way that the amount of electrons can go somewhere else. Now in a parallel circuit we have the Kirchoff voltage law. Now the KVL, the Kirchoff voltage law, is going to be the opposite way, where volts are constant and amps vary. The idea here is that if I look at the flow of electrons, the amount of electrons actually moving, if I have a bunch of electrons going here, by the time it gets split between this path and that path, it is now divided in two, essentially. So my flow will change based on where it's going to and how much is being used at different points. So in these two laws, you need to understand that in a series circuit, the amps are constant and volts will vary. In a parallel circuit, the volts are constant. Those are the two most important points within the Kirchoff laws. Now putting it to use. in this little problem I have set up here, I drew a circuit here with a total voltage of 100 volts. So at the power supply here, we have 100 volts. There's a resistor on the right side, R1 at 15 ohms. Resistor 2 is at 25 ohms. I recommend that you make a little VIR chart for yourself to solve with, that we can keep track of all your answers. It's easier to find what you need to find here. Well, I'm going to put in what I know so far. So right now I know I have 100 volts at total. I have at resistance, I have 15 ohms here. I have 25 ohms here. To find the rest of this stuff, I need to use Ohm's law. But with Ohm's law, I need to have at least 2 of the 3 components to solve for it. At this point, I have only 1 for each of the setups. So I want to find total resistance first. In a series circuit, it's as simple as saying R total is equal to R1 plus R2. So in this case, I have 25 plus 15, giving me a grand total of 40. 40 ohms. From here, I can solve for I total, my current total. So to solve for I total, I would simply say, cover up the I here, and V over R. So I would say 100 volts over 40 ohms, which leaves me with 5 over 2, which essentially is 2.5. So 2.5 amps. Now, in a series circuit, the amps are constant. So I already have the answers for my amps at 1 and 2. What that's saying here, so we're on the same page, is that at this point right here, there's 2.5 amps of current flow. At this point, there's 2.5 amps of current flow. At any point in the entire circuit, there's always 2.5 amps of current flow. Now from here, I can use Ohm's law again to solve for V1 and V2. Now V1 and V2 is saying how many volts are at this point right here, and how many volts are at this point right here now. So I want to try and solve for those two things. So to solve for those, I would then take my V, cover that up, and say I times R. Now to solve for the first part, I would say V1 equals my I at 2.5 at I1 times 15 ohms. That's amps there. And I come up with a grand total of 37.5 volts. That's 37.5. Now for V2, I'm going to do the same thing here, but with 25 ohms. So 2.5 amps times 25 ohms, and find my voltage total there. Now at that point, I'm going to have 62.5 volts. Now if you quickly add those two numbers up here, the 37.5 and the 62.5, we should get a total of 100 volts. I mentioned earlier in Kirchoff's laws that the total volts is equal to the summation of each point. That's what this means. That's how I solve for a series circuit using Ohm's law. Now in a parallel, it's a bit different here. In a parallel circuit, the same numbers are being used here. I have V total of 100 volts, I have 15 ohms at R1, and then 25 ohms at R2. So I'm going to again plug in my numbers I already know. So 100 volts here, my R1 was 15 ohms, and my R2 was 25 ohms. So from here, I want to try and solve for each of the components that are left open again. I need to find RT first. Now RT, resistance total, in a parallel circuit is found like this. In here, it's going to be RT equals 1 over R plus 1 plus 1 over R plus 2 plus as many resistors as you have. In this case, it's only 2, so it would look a bit different here in the end. So my RT in the actual equation here would look like this. 1 over 15 plus 1 over 25. Now, I have to solve for this, obviously, so I'm going to break this down and solve for this solution here. When you break it down, and when I find out what the lower denominator part should be, I should find that RT equals 1 over roughly 106 repeating. And then if I solve for it further, R total equals about 9.43. That's my resistance total of my parallel circuit, 9.43. From here I can find my I. So again, I'm going to say V over R. So I'm going to say for my I total equals my V, which is 100 volts, over my R total, which we said was 9.43, and my answer should come up with is 10.6 amps. Now in a parallel circuit, we know that the volts are constant. So down here, my volts are always 100 volts, 100 volts. I can then solve for I total for I1 and I2. So I'm trying to find what the current is at each of those 2 points. So at I1, right here, my current would be, again using Ohm's law, looking for my current, V over R. So I'm going to say 100 divided by 15 to find my first current, 6.6 repeating, and then my I2 would be 4. Now in this case, if I add up these two numbers, my 6.6 and my 4, I get my total amperage. So in a parallel circuit, I want to have my amperage totaling up, and in a series circuit, I have my voltage totaling up. That's how you solve for series and parallel circuits.